Hey guys, welcome back to a little bit of electronics here. Notice that we've upped the production values with a little bit of music. That's my theme music that I wrote with Sophia Mahmood on guitar. That was recorded and mixed by our brother Sinan Mahmood. Some of you might know them. At any rate, what I wanted to do in this video was to get a little bit of introduction to how I can construct circuits using operational amplifiers. Over the past few days, we've been learning about OpAmps through our Google Forms, reading all about them, answering some questions about how they behave. But because we're not in the classroom, we haven't had a chance to do the iCircuit stuff to simulate OpAmp circuits, see how they work, how they behave, and how I can use them to great effect. It's now when things start to get really, really super interesting. When we were doing transistors, we learned that you could use a single transistor to amplify a signal. And the first thing we amplified with like one transistor, the amplification is not so great. And then we add some resistors and capacitors in different ways. Things get more complicated, but the amplification gets better. If you keep on doing that, keep on studying it and perfecting it, ultimately you come to this operational amplifier. Nobody would want to build this in iCircuit, although you could. And certainly no one would want to build it on a breadboard, discrete. It's got so many transistors on it. And there's a capacitor in there and a bunch of resistors. Very, very complicated. All of that complexity that's inside of this circuit here is represented inside this triangle. So this triangle is not a black box, but it's more of a black triangle that represents all of that fancy discrete circuitry is somehow built into this as a concept. It has an input that's labeled negative. That's the inverting input. It has an input that's labeled positive. That's the non-inverting input. And what I've built here today, just for this demonstration, is what's known as an inverting amplifier. I've connected a battery to it, a 1.5 volt battery. And from that battery, well, I connect one end of the battery to the ground, the other end of the battery, I go through this 1K resistor to the inverting input. Now, the non-inverting input, I connect to ground, and then I have my output over here, this other side of the triangle here, this is the output side. And I've connected a feedback resistor from the output back to the input again. And I remember the two golden rules of operational amplifiers, that the output of an operational amplifier is going to be exactly what it needs to be to make the inputs to the operational amplifier match. This non-inverting input I'm forcing to be 0 volts, which means the output of the amplifier will be whatever it needs to be to make this input 0 as well. Since I have a 10K resistor here and a 10K resistor here, the output will have to be greater than and negative what the input is on this side. And so I get amplification. Because this is 10K and this is 1K, when I run this simulation, this op-amp is going to take my meager 1.5 volts and jack it up to 15 volts. So I'll just go ahead and start the simulator. And I see no current runs into the input. That's not the way an op-amp works. An op-amp doesn't draw current. It amplifies voltage. So here I have current flowing over the top through the feedback part of the circuit. And if I click on the output here, I discover that I have an output voltage of negative 14.99 volts. Not perfectly negative 15, but just about negative 15. My input was 1.5. My output is negative 15. 10 times larger and negative. Well, what we're going to be doing soon, it's the whole purpose of this video, is we're going to be prototyping these on a circuit board. Obviously, under the circumstances, we can't do that live, but we can do it in Tinkercad. But here, an operational amplifier is represented as a triangle. What does an operational amplifier look in a real life circuit? Well, it turns out that these operational amplifiers, of course, they don't look like triangles in real life, but they do look familiar. Here is a 741 operational amplifier. It's a microchip, an integrated circuit. All of this stuff, all of these transistors and resistors and the capacitor and everything that goes into this, all of this is built inside this tiny, tiny, tiny little package. It's really a remarkable achievement of human technology. It's got these little metal pins sticking out the side, makes it look like a bug. Those metal pins are where I make my connections when I'm building a circuit with this operational amplifier. So one of the first things that we're going to do next week is we're going to build this circuit, the inverting amplifier, but we're going to build it in Tinkercad. So I'm just going to quick go to Tinkercad here, and you'll see what I have is a setup where I have a power supply and my breadboard, and I've included here an op-amp. An op-amp, like many, many, many devices, needs to be powered. I need to supply it with some voltage so it can do the magical thing that it's supposed to do. So I'm supplying power to the op-amp, but what I have to learn here is I have to know, how do I connect things to an op-amp? Like, how do I use it? I go on the internet, I buy a 741 op-amp, it comes in the mail, I pull it out, I stick it in the breadboard. How do I know to connect it? The answer to that is I go online and I research the datasheet. This is the datasheet for the LM741 operational amplifier. It's a piece of documentation that's provided for free from the makers of the device, in this case, Texas Instruments. And it tells me everything that I'd ever want to know about this operational amplifier. By the way, typical application, here's a non-inverting amplifier using this device. And I have a table of contents and everything so I can find what I need. But down here it shows me what the microchip looks like. Every microchip has a notch on the end, and actually over here near the one it has a dot, so that you can tell which end of the chip you're looking at. And then the pins have numbers: 1, 2, 3, 4, 5, 6, 7, 8. You can see that there's an inverting input, there's a non-inverting input, there's positive voltage, there's negative voltage, and there's an output. There are 3 other pins: the offset null, the NC, not connected is what that stands for. I was thinking to myself right now, what does that mean? Then it's not connected to anything. That pin doesn't do anything on this particular chip. 6 is my output, and 5 is the offset null. The 2 offset nulls, we won't use those. All we're going to do is power the chip, plug into the inverting and non-inverting, and off we go using our operational amplifier in a circuit that we're trying to build. So back to Tinkercad, here I have my op-amp sitting astride this slot down the middle of the breadboard. Now I know what that slot is for. When I take a chip like this quad comparator here and I drop it down, I place it so that half of the pins are on one side of the slot and half the pins are on the other side of the slot. What that does for me is now this one pin, I have all of these different places that I can connect to it. And over here, I have all of these places I can connect to this pin. It makes it very easy I want to delete that guy now. It makes it very easy to, I need the trash can, trash it, to connect integrated circuits on a prototyping board. So I've pulled out an op-amp here, and I say, well, I can't remember what the pinout is for the op-amp. That's okay, because if I wave over a pin, it tells me in a little dialog box what that pin is for. This, for example, is the inverting input. This is the non-inverting input. This is the negative voltage, which here I've connected to ground. This is that offset, which I'm not going to use. Here's the output. Here's where I'm going to get my amplified signal. Here is the positive power, so I've connected that to the positive voltage from my supply. The supply voltage here can be anywhere from 0 to 22 volts. In reality, and probably in Tinkercad, I haven't tried it yet, but probably I can push it way beyond that. In reality, if I go beyond 22 volts, I'll cook this thing and it'll start smoking and potentially catch fire. So I have to be careful about that. And then I've got this not connected, and I've got these offsets here that I'm not going to use. So I have everything I need to take this circuit that I've simulated an eye circuit here with a inverting input, non-inverting input, and an output. And to build that in Tinkercad using the OpAmp as an integrated circuit package. That is what we're going to be doing going forward. And the first OpAmp circuit that I give you to build, if you can't remember how all of these things go together, you can just come back and watch this video again until you get it squared away.
Mm-hmm.